to the cloud. Love cloud. This is called Cloud 9 recording. And today, what we are going to be talking about is sorting. Okay, sorting. Sorting is going to be just awesome because sorting can make your life easier in so many different types of problems. I don't know what. Raise your hand if, or some way, let me know if you were asked that question about the absolute minimum distance between two numbers in two sets of arrays. Who got that? Yeah, I'm seeing some hands in the nonverbal feedback feature. Oh, I accidentally hit clear all by accident. Please do it again. Okay, yeah, we had some. So this problem is made a lot easier through sorting, because then you can, if you sort both arrays, which the average sort time is n log n. If it's a good sorting algorithm, that's what it will be. And then you can just go ahead and compare like the smaller of the two numbers and do the distance, and then move the smaller number up one every single time. And then you'll only have to iterate through each array once. So you end up with a n log n plus m log m for the two different arrays. So sorting is like an ideal answer. So sorting helps in a lot of different problems. You'll remember that we've gone over binary search, which only works in a sorted environment. And so sometimes you might need to sort something to help you. It can just help in a lot. And sorting also occurs, and probably obvious, like in real life all the time, right? Your photographs on Facebook are all sorted by date. You can sort your files alphabetically or by date, right? There's all these different ways to, and places that sorting appears. Same with like picking, like looking up sports statistics, or just sorting up, sorting everywhere, literally everywhere. So today we're going to talk about a few different types of sorts, and go into that. Sound good? Rock and roll. I'm seeing the heads bobbing up and down like Dwight's bobblehead from The Office, which is great. Okay, so let's first talk about my favorite quadratic sort. Okay, that is going to be called bubble sort. So things to note about bubble sort is O of n squared. So this is not really the ideal sorting algorithm. It's, it sorts, but it's not incredible. That's all. And Ohidor, yes, it does sound like a Pokemon. The bubble sort attack used by Bulbasaur and Squirtle. Okay, so the way bubble sort works, let's, I have like a little bit of a visualization here somewhere. So it's this kind of movement, and let's see if there's a better actual visualization, like a movement. Bubble sort visualization. And what this does is it's actually going to compare two elements, and it's going to keep moving the bigger element down all the way to the end of the array. And then it's going to do it again, and it's going to do it again. So let's see if there's a good visualization. Unless one of these already has a good visualization. Okay, so we can watch this. This is a really slow GIF. But you see, it compares these, and then it goes, oh, okay, well, 7 is bigger than 2. So 7 and 2 should swap. And then it's going to keep sliding, and it's going to go, okay, 7 and 4. Well, those are bigger. 7's bigger than 4, so those should swap. And then we start again from the beginning. So we're going to see 3 and 1. And it goes, okay, well, 3's bigger than 1, so those should swap. And then it's going to move to the next, and it's going to say, okay, 3's less than 5, so those should stay. Going to keep moving. 5's less than 6, keep moving. 6 is bigger than 2, so those are going to swap. So we're going to see a little swap action there, and then it's going to go 4 and 6. Okay, well, 6 is greater than 4, so those should swap. And then it's going to start again from the beginning, right? So it's going to look at that 1 and 3. Those are in correct position, so it's going to keep moving. 3 and 5, it's going to keep moving. 5 and 2, 5's bigger, so it should swap. And then it's going to move again, and it's going to look at 5 and 4. Those should swap. And then it's going to go, well, it's acting like it already knows. Oh, no, it doesn't. Good. So it's going to check. 3 and 2, they should swap. And we're going to go to the next one. Nothing. And then it should run again. And it looks like it is. Nothing swaps. And since nothing has swapped, we now know that it's sorted. So that's how bubble sort works. It's this idea of, you can think of like how big bubbles are going to be rising to the top before the little bubbles or something, right? Because they've got more air, so it's forcing it. I don't really know if that's how the speed of bubbles work, but it feels good to me in my head. And so we're going to move the biggest, and then the next biggest, and then the next biggest, and then the next biggest, and continue on. So let's think about how we might go ahead and write something like that. So, like, we're going to do these in breakout groups, but I'm going to help provide some of the pseudocode. Okay, so the first thing we're going to think about is have a is sorted variable, or we can just call it sorted. Okay, this is the way I like to think about it. There are other ways to write bubble sort, and then we can think like, hey, so while this hasn't been sorted, right? So while we haven't sorted, or while it's not sorted, so while it's not sorted, we need to iterate through this array, right? We need to, well, in order to, okay, how's the best place to explain this? So we're going to have some array. Let's pretend it is sorted already from the very beginning, right? And we're going to have this variable sorted, and we're going to call it false. And as we go through, so we're going to be like, okay, while this isn't sorted, keep going. But right away, we should set our sorted to true. So we'll set, and it will make sense in a minute, set sorted to true. And while we're going through it, we're going to keep comparing as we go through the array. So we'll iterate array and compare with neighbor. And then if we see that there is indeed a sort, so let's say this was the 4 and this was a 3, we have to swap these two numbers. So if swap is needed, then swap. And if we did make a swap, what does that mean? What logical thing can we derive? Like, oh, we've made a swap. What does that mean for our sorted variable?
You have to check it again.
Yeah, exactly, right? If we had to swap, we have to check again. So if swap is needed, then swap and update sorted variable to false, right? Because, whoops. Because if we did have to make a swap right here, we don't know for sure that the rest of this array is already done. So we are going to have to start again from the top. But if we were already given like this sorted array and we set it to true, and then we iterated through it and we're like, okay, 2 and 1, no swap there. 2 and 3, no swap there. 3 and 4, no swap there. 4 and 5, no swap there. 5 and 6, no swap there. Well, then our while loop will break because it's no longer not sorted. And so because only when we swap will we set our variable back to false. And inside the while loop, we'll set it to true. And then after this is all done, we will just go ahead and return our array. So this is kind of, if you follow this logic, you will get a bubble sort working. And I will share this logic in the chat. Any questions on this? Okay, so we're gonna take 7 minutes in groups, in breakout rooms, and try to write our sorting. And ideally, I want to do this like, I think 10 rooms is as much as I can do. Oh no. Okay. Let's see here. We're going to do pair programming. So I have to set up the rooms a little bit so that we get the right people together here. 2, 3, just because I don't want you all to be paired up with John and Jenya. Okay. I will see you all in. We'll do 8 minutes. Okay, we'll do 8 minutes. Any questions on the expectation? All right. See you soon.
We back in class?
We're back in class.
We are back.
Good. Sorry.
Mhm.
I
I
forgot.
didn't expect to be back so soon.
No, I don't know. Bye.
Hit me up with this poll. Let me see how this went for you.
Mhm.
1 through 5. What do we got going on?
We need more time.
You need more time? Okay. It's good to know. All right. We got 18 pollers. Let me share the results.
Drum roll.
This is where we're at. Mostly 3s and 4s. Some 2s, a 1. I feel like we should have had 2 1s because it was pair programming. So you guys, you and your pairs have got to be on the same page. Maybe the other one didn't vote. We should have had 1 more 4 as well. Okay. Do we need more time as a class?
Yeah.
I guess give me the nonverbal feedback feature of yes or no on if you need more time. All right. Looks like we all need more time. It's like unanimous. Okay. How much time do we need? Somebody let me know what's going on.
I'd say just a few more minutes, honestly, like maybe like 5 or
You're in the 5-minute ballpark. Okay.
5 to 3 minutes.
Brutus is saying 4. Brandon's saying 3 to 4. Yeah, everybody write how much more time you need in the chat so I'll figure out an amount. I'll do a brain aggregation. 5. Oh, good. You're going to make it really easy for me. 5. Oh, this is getting so hard on my brain. Kong, don't worry. I'm taking out duplicates. Henry, you too. Henry, you already voted with a good 5.
Don't forget to carry the 1.
Okay. Yeah, I'll pause. Danny. Welcome back. I'm going to assume that I can take the last poll and just slide it a little bit marginally forward. So I'm not going to take a new poll of this one. Unless I'm way off, then somebody should let me know. Let's go over this one. Right, so really, we had pseudocoded it and walked through the steps. So if we take this essentially literally, we will get a bubble sort. So let's go ahead and try it. So let's make our function. So we'll call this bubble sort. This is going to take in an array. Oops. And we said we were going to have a sorted variable. So let's go ahead and make that. Let's sort it. And what would make a good default variable for this?
False.
False, right? Because this variable, we have not sorted it yet. So then it says, while it's not sorted, So I can interpret that as while not sorted. Great. And then it says I'm going to iterate the array and compare with the neighbor. So let's go ahead and write a for loop. So for let I equals 0 while I is less than array.length I plus plus. Okay, and then what's my if statement look like? How are we going to check this neighbor?
So you can do like if because you would start from array at 0 or just no, if I is greater than array at I plus 1 because you're comparing I to the number next to it.
So sort of. So I is the indice. So when we're sorting, we don't actually care about how the indice compares to the elements. We only care about what the elements look like.
So array at I.
Yeah.
Okay, so if array at I
is
Greater than array at
greater
I
than
plus 1.
Okay, so if array at I is greater than array at I plus 1. So this is going to look at the current element and see if it's larger than its neighbor on the right side. So if this is the case, and array at I is larger than the array at I plus 1, what do we need to do?
change the values.
Yeah, right. So we need to swap these values. I could do this a few different ways. I could make a temporary variable and then swap them so I don't lose it. Or I can just use object destructuring to my benefit and say array at I and array at I plus 1 is equal to array at I plus 1 and array at I. Whoops. Okay, so all this does is it swaps the values. Right. I also could have written that as like a temp, where I would say is array at I, and then I would say array at I equals array at I plus 1. Array at I plus 1 is equal to temp, right? These three lines are doing the exact same thing that this one line is doing. So I'm just going to stick with the one line, but it's okay if you did it the other way.
Corey, quick
Yep.
question. So when you destructure it like that, does like the way that you destructured it, does it still like it actually swaps it with inside the actual array?
Yes.
Oh.
Yeah. This is a really sexy kind of shortcut that I really like. And then I did in an interview once, I was asked to write a function that swaps two elements in an array at the specific indices. And I just wrote this inside of the function. And the guy was like, no, that doesn't work. I went, yeah, no, that works now. And he's like, well, I'm like, yeah, this is how you can do it now. And he was like really excited when he saw that it worked. So that was cool. Right, you could also use something called XOR, where you could say like A is equal to A XOR B. Then you say like B is equal to A XOR B. A is equal to A XOR B. This also swaps the elements, but I'd rather not go into how that works. But that's essentially part of bit manipulation. This answer itself will do, but there are a few different ways to swap something. So just be aware of that. They're all created equal as in they all do the same thing. I just like doing it this way because it's one line and feels good to me. So if we have swapped, we talked about like saying that we know that we can't be certain that we're sorted yet. So I'm going to go ahead and just update my sorted to be false, which means I should have already updated my sorted in my while loop. I should have set sorted equal to true here. And that way, if I don't ever hit a swap, I will break out of the while loop. And at the end, all we have to do is return our array. So let's go ahead and try this. So I'm going to say console.log bubble sort. It's going to take in an array, and let's go ahead. Maybe I'll just make an array that I can do all the sorts with today. So let's make, I don't know, 3, 4, 2, 1, 1, 7, let's say. And we'll just pass that in there. And let's go ahead and run this code. So node sorting, and we get this nice sorted array. So it looks like it works. Any questions on that implementation?
Just one question, Corey. I'm just a
Sure.
little confused, just in terms of having a while loop and then having a for right after that. Like, how does that work?
This loops inside of the while loop. So as long as this variable says false, this code runs. And then at the end of this code running, the while loop starts again. So if the sorted is true, we're going to iterate through the entire array. If we ever make a swap, we'll start again and iterate through the entire array.
Okay, so we're basically from the beginning where we're assuming that it's false, and then as long as it's
But we're not assuming it. We made
we're
it
assuming that
false,
it's false.
right?
So while it's not false, then you're gonna loop through it. Okay, I got it.
Absolutely. And Kevin says, could we have done let I equals 0, I plus plus in the while loop? Like done another while loop inside the while loop? Is that what you're asking, Kevin? Yeah. Yeah, right? I could also have made this like a for loop too. Just like then like let sorted equal false and not shown a good way to increment it. Right? You could, like, I could have still technically done a for loop has anything. It's just an initialization. So I could have said sorted as false while not sorted. I could have just done that and then done my for loop in there. My other for loop. It's loops, you know, no matter how you write the loop, it's okay. There's lots of different interpretations. I just think this way reads a little bit cleaner than having a for loop that's doing what like a while loop says. I want my code to try to read like English best I can. So like while not sorted, set sorted to true, go through the array. If our element's larger than the one beside it, just go ahead and swap these elements. I can go ahead and make a little comment. Yeah. But that's how that's working. This is just going to run fresh with every restart of the while loop. And that's why this is a time complexity of O of n squared, because for every element, we could potentially have to do a full loop for each one to get to the next biggest, next biggest, next biggest, next biggest. And so I want you to also just, of course, let's get spun around. I want you to look at a visual like this. Like this, sorry. So so there may be a part of the exam where that involves sorts, and it's probably not too much. It's probably just visually identifying what the sort is being used by a picture. And so if that were the case, right, bubble sort would look something like this, where you have an unsorted array and you're seeing this comparison where the bigger number is the one that keeps getting moved towards the end until it finally does reach the end, and then we're starting again. And in this case, only the 6 was out. So once it's okay and we haven't had any swaps, it's safe to say that it's sorted, right? I don't know what the picture will be if it is on the test, but it would be something along with the idea of things swapping up towards the end of the array. Any questions on that? No? All right, so let's talk about the next sort, which I'm not as excited about, just because I've never used insertion sort prior to today. This is another O of n squared sort. So let's move to the next sort here. We're going to say we will have This is called Insertion Sort. And this is also going to be O of n squared. So not a great sort. Bubble sort's more famous, I think, than insertion sort, but there's also insertion sort and selection sort. But in the curriculum, it's just bubble sort and insertion sort for the quadratic sorts. And let's see if we can get a good visual of the way that works. Okay. So here we have this sort here. And so we go through it and we move it. So now we can feel like this 2 was the last thing that's sorted. And the way it moved, we grab from the end and we're essentially looking to see where we can slot in the next number. Here, we'll see it good here. So we consider the 6 now sorted. And so now we look to the next one. We go, okay, well, the 5 goes before the 6. Okay. So now we go to the next unsorted, and this gets moved. It's still bigger, it's still smaller. So now we go to the 3, and then we grab the 1. This is from our unsorted area, and we're going to compare. Is the 1 bigger than 6? No. 1 bigger than 5? No. 1 bigger than 3? No. We're going to go ahead and stick that one. Then we move and we see the 8, and the 8 is fine because it's greater than this one below it. So we consider that sorted, but then we move to the next one and insert that. We see the 2, and we're going to look, and we're going to go, is it bigger than the 8? No. Is it bigger than the 7? No. Is it bigger than the 6? No. Is it bigger than the 5? Is it bigger than the 4? And you can see that these keep moving over when we stick in the 2, and then we're going to do the same last one with the 4, where we're going to be looking and sliding these over until we find the correct place for this. And once we find it, we're going to go ahead and stick that in, and it is sorted. So it's kind of like a bubble sort, right? There's some like familiarity there, probably because they're both O of n squared. But you can see here is also a visual graph of what this kind of looks like, where we say, like, we're going to assume 85 is sorted. Then we're going to look and see if this is also sorted compared to this. And if it's not, we're going to lift that out, move 85 over, and then stick that one in. And so that pattern continues. So like here, where we have our 59, and we see it's 59 less than 85. Yeah, so that's going to go and sit there. Do our 45. That gets inserted, that gets inserted. And so it's this kind of movement. Is there any questions about that movement in general? No? Okay.
Is it
So
like a
let's go
slice?
ahead. Sorry?
Is it something like a slice?
I don't think you'll need a slice because you can just do a continuous reassignment. You could slice, I guess, but the code is kind of like sneaky. So essentially what we'll need is we're going to have to think about iterating through the array. We can set a temp. We can set a temp to the current index, current element at array I. Okay, so and then we can set the second variable of like a j. So set a j to be I minus 1. Right, so iterating through the array, and we should start this actually, start at 1. So we're starting at 1 because we always assume that the very first element in the array is sorted, right? So when we look at this array, here we go, okay, 3 is correct. This is up to here, we're sorted. So then, as we iterate, so we're starting here, we have a j that's going to be pointing to this indice. And then, well, this is already in the right area, but we're going to say like, hey, while our j is greater than greater than and equal, greater than or equal to 0, and array at j is greater than our temp. So if it's not greater than the temp here, right, this is array at j, this is array at I, this is not greater, so we don't continue. And then, so let's find a case where we do. So we'll keep going. So we go here. So this is now array at I, and this is array at j. And we see, okay, well, this is great. This is array at j is greater than array at I. So what we're going to do is we are going to assign this value, or sorry, we're going to assign this value to be this value. So it's essentially going to swap these two. So it looks like 2 and 3. And then we're going to assign, or that was a 4, my mistake. And then we're going to assign this value where our 2 is to be what this value is, and keep doing that. So then we have a 4, or that's a 3. I don't know why I keep switching my 3s and 4s, and a 2. And then we're going to be at less than 0, our j index. And so in that point, we'll stop and insert it. And that will make more sense once you actually see the code. But okay, so while it's greater than that, we will say array at j plus 1 is going to actually be equaling to our array at I. So that's going to update that current I position and so on as our j decrements. And then when we get out of the while loop, we want to update where our array at j plus 1 is to be our temp. At the end, return array. I know this code is a little bit confusing to look at. Yeah, I get that. It's not the greatest sort. I personally don't like it. It's not as intuitive to me as bubble sort, which I think is a lot more intuitive of just flip, flip, flipping, flip, flip, flipping, flip, flip, flip. This is more, hey, this is sorted. Is this belong here? If not, I'm going to go shift that over and compare with this. If that's not there, I'm going to shift that over. If I'm less than or equal to 0, I'm going to go ahead and stick it in the 0th place. That's all that's really doing. It's a lift, compare, no, take that out. And then, okay, here, compare these, no, okay, compare these. Yeah, that one's fine. So just go ahead and plop it in. That's more how this code is working. But it is less intuitive. But I want you to give it a shot, okay? So we're going to go back into our groups. And I should definitely share the thinking of this. Okay, try to translate this into code and see if you can get some kind of working solution for an insertion sort, okay? Let's take a poll on how we did on this one. Let me see those polls ringing in, ringing in, ringing in, ringing in, ringing in, ringing in. So yeah, my wife got mad at me the other day because we were watching Criminal Minds. Has anybody watched Criminal Minds?
Yes, that's one of my favorite
That's a
shows.
good show,
I've
right?
yet to watch
Great.
Criminal Minds.
Yeah, so
What?
we were watching Criminal Minds, and in one of the episodes, some crazy lunatic guy, he killed his wife. And so she says to me, "What? Why he kill his wife?" And so I said, "What do you mean? That's every married guy's fantasy."
Oh my
Like,
god.
why wouldn't he?
Corey.
And I will be honest, she was not pleased.
That was not smooth. That was not smooth.
Oh, no.
Not
But,
receptive. Not
Did
receptive.
you,
How
watch
did he kill
all of it?
her?
Just watch any episode. Like, have you watched all of it?
I'm still like in season 6 or something.
Oh, it gets crazy, Corey.
Oh yeah.
Corey, it gets absolutely ridiculous.
I need to
Can't
watch
wait.
Criminal Minds.
I will
Wait,
get
what
that.
season
Yeah.
are you on, Rafid?
I like whatever Netflix, like season, whatever Netflix is on. I'm on that season.
We will get there. We will get there.
So wait, did you watch when like Hotch's wife, the thing, or not?
Yeah.
Okay.
We shouldn't spoil for everybody.
Oh, no one's gonna watch.
No. People watch. People take a lot of their recommendations.
Spoiled it for
Very
me.
dark. That
The
sounds
Fisher
like a
King.
very
That was
dark
one of the. That's the Fisher King, and after we did Recursion, I rewatched that episode of Criminal Minds when Spencer used the Fibonacci to find the location.
Oh yeah, that was cool.
I was like, wait, I learned this in class. Hold on.
Hang on, I can find this guy. All right, let's go over this and then let's answer questions on this and do that and everything. Ooh, Dragabasi is also a watcher of the Criminal Minds. Yeah, for anyone who hasn't watched it yet, go ahead and watch it. When that guy kills his wife, see if you can make the same joke that I made, because it's a hit. It is a hit. I still think it was a great joke, but she was a little bit less pleased than I was. Like always. All right, let's keep going. I'm gonna call this. Let's see. I'm seeing chats. I'm like, is there action going on?
We don't have wives. We've got a problem here.
Oh yeah. Well, go out and get wives and make the joke. Women, I'm sure there's an episode where the wife kills the husband.
So many.
Oh, good. Okay, so you can get ready for that. Yeah. Seahom's like, I'm gonna start watching. All right. Let's call this insertion sort, and let's just go ahead and follow the pseudocode that we made for us and see how we can do. So we said we're going to iterate through the array starting at 1. So let's go ahead and just build on a quick for loop where we say let I equal 1, array, while I is less than, sorry, brain fart there, array.length. I hate that term. Just wish there was something else. If there's another word for that, let me know. I plus plus. Okay, and so we said we're going to create this temporary variable where our current element is array I. So let's say let temp is equal to array at I. Awesome. And we said we were going to set a j. So let's go ahead and make a j equal to I minus 1. So we're going to look at the number, the space before the current element that we're on, right? So if we're on 2, we're going to look at 3 here and see j here. So we're going to give a little while loop here. And we'll say, hey, while our j is greater than or equal to 0, and our array at j, this is greater than our temp. So while these two things are true, there's a couple things we want to do. We want to do this line. So we'll say array at j plus 1. So this is the current index of the j, which if we're thinking about from where within the first iteration, this is essentially where I is. And that's going to become the value of array at j. So this is going to help us with that shifting motion to keep moving pieces forward while we're looking for an open slot. And so j minus minus. If that's no longer the case, we have to go ahead and stick our temporary in that spot, that new available spot, which is going to be j plus 1 equal to temp. And then we can go ahead and return our array. So I know it's a little weird, but let's go ahead and try it. So we will call console.log on insertion sort. We will pass in our array. And let's give it a shot. Boom. And we have success. Any questions on this? Let's try to break this down if we got some questions.
So really, it's just reassignment. That's what's happening here.
That's
right?
all that's happening here, right? We are looking at, like, let's say on our first iteration here, I is here, right? And j is 0. So let's say I is 1 and j is 0. And so we're going to look through it. And our temp will say our temp is 2. Right? So far, so good. And we will go, okay, is j greater than 0? Greater than or equal to? And we go, yep. And we go, okay. And is array at j? So array at j is 3. Is this greater than our temp? And we go, it is. So we are going to assign array at j plus 1. So this is right here to be at array at j, which is 0. So this is essentially at this exact time going to look like that.
Oh, it's a full swap. Okay.
It's not even a swap,
Yeah.
right? We've just
Uh-huh.
reassigned. We've said array at j plus 1 is equal to array at j. So array at j was 3.
Mhm.
Still is 3. So this is now also 3. The only reason we're not losing that 2 is because we have this temp here hanging on to it. Otherwise, it's now gone. And so then we would decrement our j to be -1. And we'd say, is j still greater than or equal to 0? And we go, well, no. So we break out of the while loop. And we have array at j plus 1, which means array at 0 equals our temp. So now our temp looks like this. All right, so let's keep going. I gets incremented to 2. And j becomes, because we start the for loop over. So our temp is now 4. And our j is now 1. Okay, so we say, is j greater than equal to 0? Yeah, and we say, is array at j, which is 3, is that greater than our temp? It is not. So we don't go into the while loop, and we assign array at j plus 1, so right here, to equal 4, which it already does. We go, okay, I gets incremented now to 3. We start the loop over. Our temp is now going to be 1. And our j is going to be 2. And we start this loop. So is j greater than or equal to 0? Yep. Is array at j, yeah, greater than our temp, which is 1? And we go, well, yes, it is. So array at j plus 1. So right here equals array at j. So this equals 4. And j gets decremented by 1. And we continue the while loop, because is it still greater than 0? Yeah. Is array at j, so array at 1, is that greater than our temp? Yes, it is. So j plus 1, which is going to be this slot here, is going to equal array at j. So this is going to become 3. And j is going to be decremented to 0. Okay. We continue our loop. Is it greater than or equal to 0? Yes. Is array at j, so is our 2 there, greater than our temp? It is. So we are going to set array at j plus 1. So right here is going to equal array at j. So this is going to get updated to be 2. And our j will get changed to -1. Our while loop continues. Is j greater than or equal to 0? No. So our while loop ends. We say array at j plus 1. So array at 0 is going to equal our temp. So this becomes the 1. Okay. And the pattern continues. I will leave it at that. Any questions on that? And I'm just going to update this to be back to some other messy array. Okay. No questions? Okay, so the important things, though, would be that you'll recognize a chart of what insertion sort looks like. So essentially, if you see a chart where things are moving from the front to the back and filling up the front first, that's insertion sort. If you're seeing things where it's moving from the back up to the end of the array, that's bubble sort, right? That's your big difference, right? Where bubble sort looks like this. Yeah, it's moving towards the end of the array. We're building. So one is you're kind of building the largest to the smallest. The other one is you're building the front of the array first. Okay. Questions? Any questions on that?
I like bubble sort better.
Me too. Me too. I like bubble sort better, but you know what I really like the most are the next two sorts that we're going to talk about. I really like the next two sorts, but I also want to give us a small break because we've been going for a little bit. So let's take a 5-minute break. So be back at 4:35. So the next two sorts we're going to talk about are Quicksort, and then we're going to talk about Mergesort, and then that's it. Okay, 4 sorts today, way more than enough. The most important thing that you pull away from this are the time complexities of the different sorts and to be able to visually recognize them. It's nice to be able to write your own sorts, but usually you don't have to. Okay, you probably won't need to write your own bubble sort anytime soon, or insertion sort. It's good to know, it's fun, but it's not as important. Let's get to the more useful sorts. So let's talk about Quicksort. Super stoked. Let's do this one. I'll just stick with the screen. All right, so Quicksort is a n log n sort. So let's go ahead, take a look, and we'll say Quicksort. Quicksort is a O of n log n time complexity, right? So this is, I guess that's called linear arithmetic, right? I've never called it that before, but I believe that is the right term. But it's n log n, which is what I often call it, right? Super duper important to remember that like real sorts, the ones you're using that are built in, those are n log n. They have to be n log n. Do not forget that. If you say a sort is linear, you better have the greatest linear sort, the first one ever made. Otherwise, say it's n log n. If it's built in. So, okay, we've got this n log n sort. And the way Quicksort works is we're going to write a recursive. So this is going to be recursive, which is cool. Obviously doesn't have to be. All recursive problems can be solved iteratively, right? But sometimes they're a lot easier to solve recursively. And so the way this one works is a base case. So when is an array guaranteed to be sorted? Who can tell me
Can you
this?
repeat that again? Sorry.
Absolutely. When is an array guaranteed to be sorted?
When it's not.
When it's 1.
When the
Sorry?
length is equal to 1.
Okay, when the length is equal to 1, that's guaranteed to be sorted. Is there a smaller array that's also sorted?
Empty array.
Empty array, right? So base case. So if an array's length is less than or equal to 1, we know for sure this array is sorted, right? How could it not be? Right? How could this not be sorted? Right? It's gotta be. There's only one element. How could this not be sorted? I mean, there's nothing in there, but it's sorted. And so the way Quicksort works is we're gonna take some sort of pivot. Okay, so we're gonna make a pivot of some kind, and your pivot can be. There's a few different ways to implement this. For now, I'm gonna always make my pivot. I'm gonna think of it as just like the last element, right? So make a pivot of some sort, And what the pivot means is we're going to look at this element, and then we're going to compare every element in the array and check how it is on the pivot. Does it belong to the left of the pivot, or does it belong to the right of the pivot? Okay, so we're going to check each element, and put left items in left array and right items in right array. Right, so what does that mean? Let's say I was looking at this array, and I decided that my 7 was the pivot, right? So I took the 7 out, and I was like, all right, my pivot is going to be 7. And I'm going to go through this array, and I'm going to have some left array and some right array. And as I'm iterating through, I'll go 3. Does this belong to the left or to the right of the pivot?
Left.
Left, right? Yeah, excellent. 2, where does that belong?
Left.
Left. 1. So I kind of chose an odd number there.
Yeah.
Right, so these all belong to the left. So then I can make this recursive call on my left side as well as my right side. And I know that my pivot really belongs in the middle. So let's pretend again. So let's pretend that this is now the array. Okay, so now we have this array, and I take, oh, for the love of God, hang on, let me just make this a 2. I want to have something interesting here, right? So this is our array. I should update the other one, whatever. And so I'm going to take my pivot, and let's say my pivot is 2. And I've got my left. Oops. My left, which is going to be some array. And I'm going to have my right, which is some array. And I'm going to iterate through. So 3, left or right of pivot?
Right.
Right, nice. 1,
Left.
left,
Right.
and right, yeah? So we're here. And so then I would be calling my quicksort on my left again, as well as my right, and placing them in the middle. So let me keep going. So we have our left call. So our pivot is going to be 1. Okay, so we have our array. I'll have a pivot, be my 1. I have my left. So for this, I can arbitrarily decide which side it belongs on, if it's a duplicate. I could also give it their own array if I felt like it, but we'll just say that. And we'll do the same thing with our right. Where we have this left is 3. My pivot, we'll say, is 4. And my right is empty, right? So this is interesting because if you think about all of these calls and you were to line them up, we would have left, pivot, and right. So this would become, if we put them in left, pivot, right order, we would have a 3 and a 4, right? And this has to do with our right side of this one. And we do our left side of this one. So if we think of the order of left, pivot, right, this gives us back some 1, 1, right? Now, these are in reference to this left and this right, but we know a 2 is in between these left sides and right sides. So we end up with 1, 1, and now our pivot, 2, and now our right side, which is 3, 4. And then if we keep going, we see our right side was empty here. Our pivot was in the middle, and we have our left side, which is what this turned into. And so this eventually goes, we say our left side. So 1, 2, 3, 4, and then the pivot. And then our right side is empty. And you'll see we actually sorted the array that way. Yeah, we can definitely use concat Henry, or we can use the spread operator. So this is really cool, and how that works. Let's see a visualization of this one. So in this case, they're taking the middle, and they're taking everything from the left and everything to the right, everything to the left, to the right, left, and right with these pivots. And you'll know that it's a quicksort visualization if they're splitting it up that way and it stays like that, where you'll see, like, if you just read the leaves of this tree, the bottom row, they'll all be in the right order. That's kind of like one way to identify a quicksort. And let's see if there's actually a cool visualization for us to watch. Quicksort visualization. Okay, this is, I guess, oh, it's optional. Well, I don't care about it being. Okay, so we see this, so let's go ahead. They're selecting the 3. Let's just, you know what? I'm not in love with this visualization. All right, we'll see if the curriculum has it. Yep, so this is them taking a pivot, moving everything that's smaller than the pivot to the left, everything that's larger than the pivot to the right, and this pattern continuing all the way down to all the leaves reading in the right order. This is a really cool sort. End log n. Let's just finish writing it. Base case, if the array's length is less than or equal to 1, array is sorted. Make a pivot, check each element, put in left side, right side. Call quicksort on each side and return all elements in order. Okay, so let's go back into our groups and see if we can write our own quicksort. I think it's a bit more intuitive, actually, than the insertion sort. But that doesn't, you know, it's up to you. Any questions on expectation there? All right, so let's give ourselves, let's give ourselves 15 minutes for this, and I will see you all soon. All right, let's show me the money in this poll. How did this go? 1 through 5. We got some doses, some treses, some cuatros so far. To answer, to just get ahead of the question, no, I'm not a native Spanish speaker. I know you may be surprised because I'm really good at Spanish. Muchas gracias. But
Stop banging by the
what, Deja?
I'm sorry, my son was banging.
Oh, no, that's okay. I thought you were complimenting me. This is our poll results, right? We are mostly hanging around. Thank you for clearing the big elephant in the room. Oh, de nada. De nada, El Henry. Me llamo Corey. Yeah, so we're mostly 3s, some 4s, some 2s. Uno. All right, let's go over this one. Let's talk it out. I absolutely love this one. So I'm really excited to share this one. The next one is my favorite. I've been saving the best for last. I'm not gonna lie. I'm one of those people that eats all of the Skittles that I don't like as much before I eat the right Skittle. I should have started with Insertion Sort. That's my least favorite, but I didn't. Just
All
because
Skittles are created equal. That's just,
yeah, all sorts are not created equal. All right, so let's go ahead and talk about this one. Right, we got our const. We're gonna call it the quick sort. It's gonna take in an array, and we talked about this base case. So in the event that I love seeing the Skittle comments. That's yes. Oh, okay, yeah. I really like the purple Skittles as well, Henry. Okay, I got to get some Skittles. My wife had Skittles, and I was like, "Where the fuck did you get those?" She's like, "I ordered them," and I'm like, "Oh, do you have any left?" And she's like, "No." Oh, I'm gonna kill my wife. I'm just kidding. Okay, let's talk about that base case. So if the array dot length is less than or equal to 1, right, which is really less than 2, but I like to say less than or equal to 1 because I feel like that reads better to someone else than less than 2, because then they have to go like, oh, okay, so 1 or less, which is really what this already is. Then we are just going to go ahead and return that array, right? Because that array is sorted. We know that that array is sorted. Otherwise, we can go ahead and make this pivot. So let's go ahead and take a pivot. And, right, our pivot, so I'll explain to you, we'll get to it later. But for now, let's go ahead and just make the pivot be the last element. So I'm just going to pop off the last element of my array and make that a pivot. I go, great. Let's go ahead and make a left side and a right side.
You have an L on line 83.
Thank you. Hey, Ashia, where were you on that one?
My finger was caught on the mute.
Oh,
I was waiting. I was trying to make a come up off of a shield slip.
I love it. Shots fired. We've got competition now. I love it.
Choo choo.
Dun, dun, dun. Okay, so we've got the left side and this right side array. And then we can just go ahead and iterate through our array, right? So we can say like array dot for each element. And here I can just do a little bit of a check. So like, hey, if my element is less than my pivot, then that belongs in the left array. So that's going to be left dot push L. Else, I know that that's going to belong in the right side array. Right? So in this one, I am okay. I've decided that if there's a duplicate, it's just going to go in the right side always, right? I'm handling that. Yeah, I know. I'm in a room without air conditioning too, so it's heating up. I thought it was just me, but no, it is the temperature. Okay, so then from here, we can go ahead and call this quicksort because we've got to still sort our left side. So I know I've got this. I gotta sort my left. So I could say like left sorted. I could call it like that, and be like that's gonna be quicksort of my left side. And I could also have my right sorted and call that quicksort of my right side. And so these will go ahead and run before we get to these lines. And then at the very end, I can just go ahead and return my left sorted, my pivot, and my right sorted, like so. And then this array will automatically be sorted. And so let's go ahead and try it with our array here. And we will call console.log on our quicksort. Pass in our array. Ooh, I'm gonna need a tank top. You have to get hot and cold in here. And we can see that it does indeed sort. So Brandon's asking a great question. He said, it doesn't matter if it's equal to the pivot. So in this scenario, I don't care if it's equal to the pivot. I'm just gonna go ahead and push it to the right side. So I'm determining anything that's in the right is going to get added to the pivot. Can anybody tell me what could potentially suck from something like this?
Side effects.
Okay, yeah. So there is. So yeah, I hear you. So there is a side effect, right? We are mutating the array. We've been mutating the array up to this point. I'm gonna accept that as an okay side effect because of the way JavaScript's sort method is mutative. That is different. That's language dependent. In Ruby, there's a mutative and a non-mutative sort that you can decide. Pretty cool. But JavaScript just has this one mutative sort, at least that I'm aware of. So I'm okay with that. Can anybody think, like, what's the time complexity of this? Like, we kind of talked about it, but
N log n.
yeah. So we said that this time complexity was n log n, right? Because we keep splitting these things in half, but we still have to go through every element. Now, if I had a pathological input, could I change the time complexity of this to always be the worst case, right? So it's n log n on average case here. But what's the worst case scenario?
Linear?
Sorry?
Nothing.
I couldn't hear you. Okay.
Linear will be the
Oh,
worst.
linear? Is that what you said?
Yeah.
So linear is actually faster than n log n. So that would be like
Oh, that's the best case.
the dream. There is no sort that is linear,
Oh,
unfortunately.
Maybe
And-
like a quadratic.
Although a best case for like a bubble sort, I guess, would be linear because we wouldn't have to do any swaps. So yeah, but yeah, and quadratic. I'm hearing that as well. Excellent, right? So we could put in data in a way that always ensures I have to do everything, right? So if like this was my pivot in the first one, and I had to go through all of this, and these were all on the left side, and then this was my pivot, right? If it was already a sorted array, I believe I would be doing an n squared, right? If it was like 1, 2, 3, I would go, okay, let's take my pivot. I'm going to take everything on the left side, pass it in. All right, I'm going to take my pivot, take everything on the left side. All right, I'm going to take my pivot, take everything on the left side. I'm going to take my pivot, take everything on the left side, right? That sucks. So it's actually better to write Quicksort technically with a random pivot. So like, let's update this code in a way. So let's say instead of popping my array, I keyed into it and I assigned my pivot to be math.floor of math.random times my array dot length.
You have and.
Thank
Okay.
She's back.
And guess who's back? Back again. Right. Sorry? Okay. So this will give us this pivot, but it's not mutating my array, right? So I could potentially add like my own like equal to pivot, right? I could do this too.
Question.
Yep.
Why are you starting at a random index and not in the middle in line 83?
So the thing is if we know, or if a user were to know where the pivot would always be in a quicksort, they could put data in to make it so that you always have to do n squared, right? So if my pivot was always in the middle and I had some array that was like, let's figure this out. We'll say 1, 2 to 5, 3, 4, right? I would take the pivot, take everything on the left side. So then it would be 1, 2, 3. But let's say this was actually 4, 3, right? So we'd have our pivot, we'd take our left side. So now our left side would be 1, 2, 4, 3. And let's say we take it in the middle again. So then we have our left side again, which is now 1, 2, 3. Ideally, I would have had that like this again. So let's just update that. So we'll put our 3. I couldn't design it ahead of time because it was a little hard for me to think about it. And then we'd have to put everything on our left side again. Right? So if we always took the middle, we could still control where that pivot is. And if we knew where the pivot was, I could still put in an array that made it take n squared times. But if we take a random pivot, there's no way for the user to purposefully make it take n squared. So on average case, it will take n log n. Does that make sense?
Yeah.
Okay, cool. All right, so let's keep rolling. So let's make this equal to pivot. And so now we'll just do a little bit of different logic. So now we'll add like an else if element is greater than pivot. Else, we'll go ahead and push it in to our equal to pivot. So now we have this random pivot with each iteration. We have our left side, our right side, and all of the numbers that are equal to our pivot. And as we iterate through our array, if the element's less than the pivot, it's going into the left side. If it's greater than the pivot, it's going to the right side. Otherwise, it must be equal to our pivot. So then we can do the same kind of logic here, but we'll just also do equal to pivot, like so. And we have an error. Array is not defined anymore. Great. Let's see. Okay, good. I didn't think there was anything wrong with the code. Okay. And so this would be a slight improvement on the previous one because it's taking a random pivot. Again, the number one thing I want you to take away from this is that Quicksort is an average of n log n. In worst case, it could be quadratic. And by taking a random pivot, you kind of stop that worst case and make it an average case. And I want you to be able to identify a quicksort from a graph, a diagram like this. This person is taking the middle as their pivot. But, right, anything can be your pivot. It's best practice to make it random. Okay, any questions on that? Anything at all? Dun, dun, dun. No? Okay. We will move on
I have
to
a
my
quick
absolute.
question, Corey.
Yes.
For the first example, right here in the last problem we did, you did const pivot equals array.pop.
Yes.
You have to definitely remove the last item, or could you just do array.length -1?
Yeah, you could do the array.length -1, but if you were doing that, you would probably want to have some spot for your equal to, because the idea is you definitely want your arrays to get less and less as well. So like once we already have identified that that element is the pivot, we probably don't want to re-put it in the left or re-put it in the right because that belongs in the middle.
Oh, okay, gotcha.
That's all. Yeah, that's a good question.
All right, thank you.
Thank you. Okay, I'm so excited for the next one. This is by far the best sort ever. Okay, this is really cool. This is called Mergesort.
Oh, real quick, can you go
Yes.
to the beginning of the right here? I just wanted to see your base case. All right, that's all. Thank you.
No problem. Okay, so our Mergesort is O of n log n guaranteed. All right, this is cool. No matter what, our Mergesort is always going to be n log n. Okay, so this is like the best. This is really cool. This is also recursive. And made up of 2 functions. What? Yonghua? And this one is cool. So let's talk about how this works with a visual graph of this. So this is what a merge sort looks like over here. I don't know how to make this the full page. Maybe I can click on it again. Nope, that always happens. Does anybody know like how to make that?
You can open in a new tab.
Open a new tab?
Open image in a new tab.
Okay.
And it opens next to it in a new tab.
Ooh, thanks. Brilliant. Genya, I love it. Very cool. Thank you. All right. So this is what our merge sort. So remember this visual because this is kind of what merge sort looks like. Oh, yeah. You don't like how it's beautiful? It looks beautiful, Brandon. So the way this works, it's kind of like magic. So there's two phases. So we have a merge sort function that's going to be recursive and continue to split itself in half, just straight up in half. So we've taken this original array and we split it right, in the middle, right? So we've got the left side and the right side. It's not based around a pivot at all, okay? And let's follow down the left side path for now. And we're just going to split in half again. So we have 38, 27, 43, and 3. We're going to split it again. So now we have this array 38 and this array 27. Now, what can we know for sure about these arrays?
Length is, there's only one element in the.
Right? There's only one element in the array. So what does that tell us about it?
It's sorted.
They're sorted.
It's sorted. Exactly, Doug. Right? This array at this stage is now sorted. So once we have a sorted array, we can start merging two sorted arrays. So we take these two sorted arrays and we're going to merge them into one. So we get 27 and 38. Same with these two. These two sorted arrays, we're going to merge these into one sorted array. So we have 3, 43. Same with these two, 9, 82, and this one just remains 10. And so here we are merging again. Okay, sorry about, I don't know if you can hear those loud motorcycles. I apologize. Here we're merging again two sorted arrays. So we're going to look. And we see, okay, 3 is greater than 27, so 3 goes in. And we check, 27 is the next small, so 27 goes in. Then out of these two, right, 38 is the small, so 38 goes in, and 43 goes in. So then we have this sorted array. These two sorted arrays got merged into this sorted array, and then these at the end also go ahead and get merged. Okay, so we're going to do this one in 2 parts. So the first part, this is something else I've been working on. All right, so the first part is I want you to write a function called merge that takes in 2 sorted arrays and returns a new sorted array. Okay, so it's going to look something like merge, array 1, array 2, and this is going to be sorted, and this is going to be sorted, and I want a new array returned. All right, based off of how much time we have, I'm going to give you about, let's say 10 minutes, and I want you to think about, well, how am I going to write this? Think about how you would do it with just your brain, like how like if you're walking through and you have 2 arrays and how you know which index or where we should go first. Because and hint, think of the 0th. That's your hint. Oh, buenos dias, que lo que?
Jonathan Shave?
Hey, low K.
Okay.
No. Hola,
You look
¿cómo
mad young,
estás?
bro.
Ah, sí.
Henry,
Yo.
See, correct us.
mi amor.
Who's me? Who calling me?
Me more.
On me.
Yeah.
Wow.
The love. Back to
Boston.
love.
Is it
Yo.
hot in here or is it the
Yo,
weather
it got
outside?
mad hot in here, bro.
It's
What's
muy
up?
caliente,
So
you know.
quickly.
Aquí.
Very
Uh,
caliente. Very, very. I agree.
Too hot to handle. No
Oh,
comment.
yes.
Coding after dark.
Sí. Mis manos es muy caliente.
Coding in dark mode.
All
Proceed
right.
18 plus.
So tell me what do all these three, like we're getting a lot of threes on each one of these.
Okay, so we
What,
tried
what do the threes mean?
like me and Doug, we tried to we got sort of tripped up towards on let me share my screen. If it's okay if I can share my screen.
Yeah, of course.
All right, so let me do that. So we're gonna share the screen here. So this is what we were working on, and our idea was to take the two arrays and put them in one array, and then sort that array. You know, like that way, like
So
they're ready
that
together.
defeats the purpose.
Yeah. Yes.
Okay, I hear you.
Because I figured it'd be a way to
Because
merge
the
them.
whole thing is that they're already sorted. So like, all right. Let me share my screen here. I
Yeah.
think I can
Yeah,
overpower.
you can override it.
And let's like talk about that. I appreciate you showing me that, Marvin. That kind of gives me some. So let's pretend we have these two arrays and they're both sorted, right? So I'm going to have array 1. And let's pretend that this is 3, 4, 6, and 9. And I have array 2. And I'm going to pretend this is 1, 5, and 7. Right? So I have 2 sorted arrays. So if I asked you to sort these, do you think that you would go 3, 4, 6, 9, 1, 5, 7 and sort that? Would that be the easiest way or harder?
Probably harder.
Well, let's pretend we had an array. What number would I put in here first?
1.
Okay, how did you do that?
Just looked at array 2 and just that value is like less than anything in array 1. At it.
Okay, did you look at 1 compared to 9?
I mean, initially I looked at 1 compared to 3.
You looked at 1 compared to 3, right?
Yeah.
And you put 1 in here, you said?
Yeah.
Let me just make a duplicate of these so we can go back. Okay, so you put 1 in here.
Yeah.
All right. And let's say I remove 1. Okay, what goes next in this array?
3.
Okay, how did you do that?
I looked at 3 in comparison to 5.
All right, so you looked at 3 and 5, and you decided that 3 was less.
Oh yeah, I actually look at 3 and 4 because that's like the next smallest.
That's not what you did. You put
Wait,
3 and 5.
Okay. I did 3 and 5. Yeah.
And then what goes next?
Then it's gonna be 4.
Okay. How did you do that?
I looked at 4 and I looked at 5.
You looked at 4 and you looked at 5, and you decided to put 4 in here.
Yeah.
And we'll take 4 out of this array. Okay. And then what goes next?
Then I looked at array. Okay, so like I think I'm starting to get the pattern. Then I looked at array 2, and 5 goes in there next.
Right. Okay. And then what?
It's gonna be 6. Then it's gonna be 7 and 9.
Right. 7. Okay. And now this array is empty. So we can just concat this array with these arrays. And
Yeah.
we have 9. Right. So if we take things that are sorted and then we just slam them together to make an unsorted thing, we essentially destroy the data that we had in the tools that help. When we have data that's already sorted, we have a lot of things we can do that are going to help us. And so by doing it the way we just did it, right, we just did a loop essentially through those two. And all we did was look at the 0th index of both.
Yeah.
And in doing so, we made our lives really easy. So let's go ahead and think about how we could do that programmatically. So let's go ahead and make our output. So I'll say const output, and we have this empty array.
Right.
And so what kind of loop would make sense right now?
You could probably do like a while loop maybe, because
Yeah.
While loop.
yeah, we want to check to see if I'm guessing if they either have like if they have, since we're removing them as we're doing them, maybe if they have lengths.
Yeah, exactly. We want to make sure that they both have a length. So I can say, hey, if while array.1 has a length and array2 has a length, I can go ahead and do stuff. And so
Yeah.
what is that stuff? Somebody else, what's the check we want to look for here?
You want a condition statement there because the while loop is just
Right?
giving it a reason to run. So we could put an if statement. So if and there if array1 at index array at I is,
Well, we don't have an I.
oh, we don't have an I, so we need to declare the indices.
Did we when we did this walkthrough, did we use an I?
No, we didn't.
What do we use?
A 0.
0, right? Because all we cared about, because they're sorted, was the first element.
Oh yeah, if
Okay.
if the first index of the first array is equal. If array doesn't-
So what do we do here? How do we
That's
move?
If it's
What's this check?
is equals to
If it's greater or less, I think.
greater than.
What do you mean by greater or less? I think it's one of the.
If it's greater, yeah. If it's greater than array2 at the same index, we're making it.
Okay. So I'm gonna do a less than, just because I think it's a little bit more readable in that sense, because I'm comparing this one as my focus. So if array1 at index 0, so if the first element in that is less than our array2 at 0, what do I want to add to my output?
Array1 at 0.
Okay, but how do I pull it out at the same time?
You could pop it.
You can
Shift
shift it.
Shift it. Exactly.
Oh, okay.
Else, right? I just do output dot push array2. Whoops. Dot shift.
return output.
So if I return, let's see what happens when I do this. This is good. All right, let's talk. So we go console.log and let's call merge, and
You
we'll
still
pass.
have to concatenate.
Yeah, exactly. But I want people to see why we can't just leave it like this first. You're totally right though, Doug. All right, so if we do it like this, right, we get this 1, 2, 3, 4, 5, 6, 7 up to here, but we don't get that 9 in there. But that's because we still have one left over, right? One of our arrays is empty before the other one is empty. So the while loop ends prematurely. So to get over that, as Doug says, is we can concatenate or just use the spread operator and say, well, I don't know at this point which array it is, but I can just spread over both of them because it doesn't matter if I spread over an empty array, it just will be empty. So if we make just that minor change, right, we end up getting exactly what we want. Which is pretty exciting. This can be cleaned up if we wanted to. We're always pushing into output. And we're just determining here based off of this. So I can put a ternary inside of my push here, where if it's shorter than that, I can do that. Otherwise, array2 dot shift. And then I can remove all these lines of code.
Array2 in line 124.
Thank you. Right? This does the same thing, just a little bit shorter. I don't know if it's more, it's probably less readable. Maybe we should go back to a more readable time. So I'm going to comment this out for those who like playing golf, though. That's available. We're running low on time, so I'm going to go over the other one, and then we can talk about it more tomorrow. The warm-up will be to code your own. All right, so don't forget it. Right, keep practicing. But essentially, we've got this merge that's going to take these arrays in. But we also need to have this merge sort. That's the real goal, right? So let's go ahead and write that. So we say const merge sort, and this takes in our array. If we establish that this is also a recursive function, we said, right? We saw that it keeps splitting up. So when's our base case here?
When the array has one element.
Yeah, right? When the array has one or less elements. It's the same base case as our quicksort. So we can say, hey, if array.length is less than or equal to 1, just go ahead and return our array. This is now a sorted array. Otherwise, we want to split this. So I can find the middle index, const mid index, and I can do that with math.floor of array.length divide by 2. Right? This is going to give me the middle index of our array. And now I'm just going to take a left side and a right side. So const left. Well, I'll show you the way I really like to write it. I'm trying to like make it more clear. But all right, I'll just do it like this. That's okay. Left, we'll say, is array.slice from 0 up to mid index. And then we have our right, which is just array.slice from mid index to the end. Right? And so we want to continue to call merge sort on both of these. So we'll say like const merge left, which is just going to be merge sort of our left side. And we'll have a const merge right, which will just be merge sort on our right side. And then once we get to these points, these are sorted arrays because the merge sort doesn't end until it hits this base case. It's going to keep happening until we actually get these sorted arrays. So then we just have to merge the two sorted arrays, which is where our function up here helps us. So now we can just go ahead and return merge of merge left and merge right. And this is a really cool function. Let's go ahead and, let's go ahead and try this with a previous array. Where we log merge sort array. And when we try this, it works. Pretty cool. That is really cool. This all could be written in like for those golf players out there, right? This could all be written like this. Oh, like this. It's the same code, just taking the middle index, and then I'm returning merge, where you can actually see I'm calling merge sort of the first half here and merge sort on the second half. This is for you golfers out there. Plain code golf. For everybody else, maybe this is more readable for you. Up to you. Any questions on this and how this is working?
So essentially, it's splitting the array into two arrays, right? Utilizing the middle index and then calling merge to just, after it sorts it, just to put them back together, splitting them up and then putting them back together in the end.
Yep. So yeah, let's go back to this picture, right? It's taking this array and it just keeps splitting them in half over and over again until we finally hit these sorted arrays, even though there's only one element.
Yeah.
And then we're calling merge on these two arrays at a time. So we're merging these two,
Then merging
these two, merging these two. And then when these keep bubbling, then we're merging these two and merging these two. And then we're merging these two, and we end up with that sorted array.
That's pretty cool. It's very sleek.
Yeah, and it's guaranteed to give us, it's guaranteed to give us an n log n time. There is no pathological data somebody can put in there to force us not to, because we're always splitting in half. We're not splitting on a pivot. We're just splitting straight up in half every time until we reach the bottom. Any other questions on this?
So does that comparison make it so it's not linear? Because essentially we're just declaring two new variables when we split it in half, right?
Where are we talking about?
Like the runtime. What makes it run longer than linear? Is it
Oh, well, we're still having to merge each element, right? So these are all splitting it in half, although we are slicing, so we really are going all the way through. But essentially, if we could just cut these in half, right? This is part of the log n part where we're splitting things in half continuously. But then here is all the elements of the array, and we still have to iterate through all of them in order to put them back together. So that's where the n part of it is. And that's why it's n log n. Does that make sense, Doug?
Yeah.
Okay. Good question. Any other questions on this one? It's a wild search sort. The first time I ever saw it definitely blew my mind. I'm hoping that it's blowing your mind as well. How do you feel about merge sort? Okay, cool. And Paul, I'm going to share the results. Yeah, so pretty much the same as always for today. It's been 3s and some 4, some variations there. So tomorrow's warm up. I am going to ask for you to write your own merge sort. So I'll try to do it from scratch. Try not to look at the code. Anything is better than Quicksort. I'm struggling. Yeah, Quicksort. I like Quicksort. I just don't like I do not like Insertion Sort. But merge is best. Yeah, I agree. Merge is best. It's a beast. It looks beautiful in its little graph here compared to Quicksort, which looks okay, but not as beautiful. And then we had Insertion Sort today, where it looked like that, where we're building up the front first, and we had our bubble sort where we were building out the back or the last half first. Okay, so that's everything we covered today. Oh, I wasn't sharing the screen when I did that, was I? Let me try one more time. Just a reminder of the visuals of what we did today, right? We have our visual of our Quicksort, where we're operating off of our pivot and taking the left sides of that pivot and the right sides of that pivot and moving until we have a nice sort along, you could call those all the leaves. We have our beautiful merge sort, where we just keep splitting in half, and then once everything's sorted, we start building them back together, sorted. We have our insertion sort, where we're building up the front as we're moving down. And we have our bubble sort, where as we're moving down, we're essentially swapping to make the biggest elements at the end first. So we're kind of building backwards. Okay. Good. Any questions on any of those at all? All right. Well, I'll be around for a little bit. But that is the end of the day. Work on whatever you need to work on. Well, it's 3 minutes. Have a good rest of your day. I definitely encourage you to keep